Hello everyone, and welcome to today's webinar, Rackspace Best Practices for DevOps on AWS. Thank you for joining. You'll have the opportunity to submit questions to today's presenters in the questions pane, and we will get these together and address them during the Q&A session at the end of today's presentation. If we can't get to your question, we'll plan on responding to each of you personally via email, and the slide deck will be available through SlideShare along with a recording of the webinar 2 to 3 days after the conclusion of this presentation. So keep an eye out for that email. My name's Lex Crosette from Amazon Web Services, and I'll be your lead-off speaker and moderator for today's webinar. I'm pleased to have my colleagues from Rackspace, Eric Johnson and Jerry Hargrove, with me today, as well as our customer in common, Larry Scott from ScriptDrop. I'll start off with a high-level AWS DevOps overview, and then the Rackspace team will dive in to explain these tools and their application in depth. We'll also focus on the use of DevOps techniques with new technologies such as microservices and containers. ScriptDrop will run through their use case in some detail and explain why they picked Rackspace and AWS as a platform. Finally, we'll try to finish up with 15 minutes to spare so that we can all answer your questions. DevOps is the combination of cultural philosophies, practices, and tools that you can use to improve your ability to deliver applications and services at high velocity, evolving and improving your products at a faster pace than other organizations can using traditional software development and infrastructure management processes. You can use this speed to better serve your customers and compete more effectively in the market. There have been some interesting and fairly hyperbolic statements from the venture capitalists world saying software is eating the world. With respect to cloud computing and software is definitely eating the infrastructure creation world. And to some degree, software is also eating the security world, since it's possible to build and deploy applications, the related infrastructure and security methods using code, and then test all of it to look for errors, just as you would have tested application software only in the old days. While it is certainly possible to use DevOps techniques in the on-premises data center world, it's faster, easier, and much more approachable to do so on AWS. AWS provides a set of flexible services designed to help you more rapidly and reliably build and deliver products using DevOps practices. These services simplify provisioning and managing infrastructure, deploying application code, automating software release processes, and monitoring your application and infrastructure performance. I'll do a high-level overview of these. After today's webinar, we hope that you'll be able to return to work with a renewed enthusiasm for bridging the gap between development and QA and your infrastructure team. You can use code to describe the application, the infrastructure, and the deployment process, and test all of it using software methods. You can continue the bridging exercise to work with your security and compliance team, rather than waiting until a system is deployed and then running through a checklist to see if it matches security standards. It's possible to reflect those standards and best practices in code and test them for correctness before the fact. As we talk to customers at AWS, a key pain point is the ability to release software more quickly, avoiding and eliminating downtime, and getting rid of those awful release readiness planning meetings where you review a deployment runbook and think about how to recover from a failed deployment. If you want to deploy software many times per day or per week and increase the velocity of your teams, you need to adopt DevOps techniques to do so. Using AWS technologies can make this easier. The AWS developer tools are inspired by the same DevOps tools used by Amazon's internal teams and help you use software development best practices used by Amazon. Amazon's engineering teams function like small startups, with each team responsible for everything from collecting customer feedback and writing requirements to owning the development, test, deployment, and operations of their services. Amazon created developer tools to help its teams independently release updates to their customers more quickly and in a self-service manner. You can use these tools and services on AWS to get started quickly. All you need is an AWS account. There's no software required or software to install. Many of the services are fully managed, meaning that you can take advantage of AWS resources more quickly. You don't have to worry about setting up, installing, and operating infrastructure on your own, and this allows you to focus on your core product. These tools are also built for scale. You can manage a single instance or scale up to thousands using AWS services. These services make the best of flexible compute resources by simplifying provisioning, configuration, and scaling. And finally, there are CI/CD tools, AWS developer tools, which will help you securely store and version your application's source code and automatically build, test, and deploy your application to AWS or your on-premises environment. You can start with AWS CodePipeline to build a continuous integration or continuous delivery workflow that uses AWS CodeBuild, AWS CodeDeploy, and other tools, or use each service separately with your own tools if you wish. The Rackspace team will talk more about these in additional detail. To get started with infrastructure as code, you can use AWS CloudFormation to make it easy to create and manage a collection of related AWS resources, provisioning and updating them in an orderly and predictable fashion. I don't know if you've seen the bumper sticker out there that rides around on some cars, but the joke is that my other data center is a text file. That's the kind of capability that you can use with CloudFormation. So you can use CloudFormation sample templates or create your own templates to describe the AWS resources you want to deploy, and along with any associated dependencies or runtime parameters required to run the application. And there's an AWS CloudFormation designer. You'll also hear, as you learn more about CloudFormation, about other tools and technologies out there that offer similar benefits, such as Chef, Puppet, Ansible, Terraform, and others. You can, and this is an interesting topic which will come up later, you can build and deploy a microservices architecture using containers or serverless computing. And there's lots of strong feelings about when to use each or either. We have at AWS an EC2 container service that allows you to build a production Docker platform with very little to manage and be able to scale up that Docker container service instance without any hard work at all. We also offer serverless computing with a capability called AWS Lambda that lets you run code without provisioning or managing servers. You can code for virtually any type of application or backend service with zero administration. Just upload your code and Lambda takes care of the rest. Most AWS customers that will tell you that their goal is to log everything because they have the goal of getting to zero errors in their logs and therefore to get to the highest possible level of reliability, availability, and security of their applications and infrastructure. Really, all logs have business value. There's a joke that Netflix is a logging company that occasionally streams video. As a leading adopter of AWS technologies, Netflix exemplifies the use of logging to optimize continuous integration and deployment of applications and using infrastructure as code. You can use Amazon CloudWatch and CloudWatch metrics to monitor your infrastructure and use code to respond to failures via Lambda functions, for instance. You can use CloudWatch logs to monitor, store, and access your log files from EC2 instances and from Cloud and others. And I can go on from there, but I'll continue with a focus on DevOps. With respect to continuous integration and continuous delivery, the AWS developer tools help you securely store and version your application source and automatically build, test, and deploy your applications. So you can start with AWS CodePipeline, or you can use any of the code.star services that are out there, and you'll hear more about this from the Rackspace team and from ScriptDrop, their customer. So in general, what are the benefits of DevOps on AWS? First, you can automate systems operation. You can get started quickly and pay as you go by using our tools or your own. You can improve visibility and security into the performance of your applications and the ability to update them quickly in response to difficulties. You can leverage fully managed services to do it all, and you can scale without infrastructure constraints. So with that, I'm going to turn it over to my Rackspace colleague. Eric, please take it away.
All right, thank you, Lex. I appreciate it. We're going to climb in. Lex talked about kind of an overview of DevOps and how how DevOps works and how AWS works, and we're going to get more specific as we're going forward all the way to the point on how do you deal with DevOps and containers. But before we do that, I want to talk about some of the tools that AWS has specifically for DevOps. And so we'll jump into that. Just a little bit of an intro. My name is Eric Johnson. I'm the AWS Evangelist and also a Cloud Architect for Rackspace. I love all things development and architectural, and I'm a real geek about DevOps itself. I love automation and seeing how it can be done better and better. So let's get started. So the first tool we look at is called CloudFormation. And CloudFormation, this idea of infrastructure as code is really embodied in CloudFormation. This is AWS's native answer to how do I keep my code as, or how do I keep my infrastructure as code? And I like the idea of the bumper sticker in my other data center as a text file, but if you want to be syntactically correct, it'd be my other data center as a YAML file or, or a JSON file, and I really like that idea. So, CloudFormation supports a wide range of AWS services. You can bring up just about most of AWS through CloudFormation. It's declarative and flexible, and it supports both JSON and YAML formats. The next tool that they provide is called CodeCommit. Excuse me. Now CodeCommit, and my presentation's working to keep up with me here, so bear with me 1 second. All right, we're having issues taking control. There we go. So AWS CodeCommit is, it's kind of in the name. It's a fully managed repo service. This is where you're going to commit your code. It's a private repository secured through AWS IAM access control. It's Git compatible, but it's also AWS CLI accessible, so you can use both patterns. The nice thing about CodeCommit is it's right in your AWS account. That allows you, the security is kind of built in automatically. So that provides you a place, again, that gives you a Git compatible repository, and it ties in with, the code pipeline and different tools throughout. So the next tool that we're going to talk about is called CodePipeline. Now, CodePipeline it's the overarching tool that it orchestrates the rest of them. So CodePipeline is going to listen to code commit and watch for new commits coming in. It's going to then, call on code build to build stuff. It's going to call on CodeDeploy to deploy stuff. It's going to call on Lambda to do kind of, whatever you want. So, Lambda's kind of that, the super toolbox that you can do anything with, and it's tied in with CodePipeline, so you can send SES messages or SNS messages and do all that. With CodePipeline, it's really a workflow modeling. You're able to say, okay, build this, test this, deploy this, or test this, build this, and then get authorization to deploy something. It has its AWS integrations like we talked about. It also has third-party integrations. So if you do want to use Jenkins, or you want to, there's different things that you can use where you may not want to use CodeBuild to build and test. You may use something else. So it'll ship the artifacts out, let you do what you want in a third party, and then let those ship them back into CodePipeline. So it handles the, again, the overall orchestration. All right. Next tool we're going to talk about is AWS CodeBuild. Now this is the newest tool brought by AWS. This was announced last year in 2016 in the AWS reInvent. And to me, this is kind of the missing piece. This is used to build and test code. It takes pre-configured build environments, or you can customize your own. It is fully configurable, has centralized monitoring on it. And really, if you think about it, the way it works is, I'm going to have what's called a build spec file, and it's going to sit in the root of my project. And when I load my project up, when CodePipeline gets my project and passes it to CodeBuild, CodeBuild's going to read that build spec. And the build spec is literally just a set of command lines. So if you can do it from a command line on your machine, you can do it in CodeBuild. And again, that gives you tons of flexibility. And you can bake, you can bake a lot of stuff into your environment because it's a container that's spinning up, or you can spin up just one of the pre-built ones from AWS and install things as you need. So CodeBuild really kind of rounds out the suite of DevOps tools. The final tool we're going to talk about is CodeDeploy. CodeDeploy is all right, I've done all my continuous integration. Everything's continuously integrating, but now I need to deploy it. So that's exactly what CodeDeploy does. It's automated, repeatable deployments. It does. Now, here the fun part about it is it'll deploy into AWS EC2s, obviously, that makes sense, but it'll also deploy into on-premise deployments. So if you have a hybrid setup, you're not stuck with, okay, I'm going to deploy to AWS through my CodeDeploy, but then I have to manually deploy to my on-premise. You can easily maintain and control those as well. It provides rolling and blue-green updates, so you can roll out to partial machines, or you can set up a whole new one and switch over. Easy to roll back and centralized monitoring, which is critical in a CI/CD operation. When that monitoring happens, when the flags go off, you're able to roll things back. So that gives you a little bit of overview on the DevOps tools that AWS provides. There's a couple more. I'm going to let Jerry tell you about those as he starts climbing into containers and DevOps for containers. Jerry?
All right, so thanks, Eric, and welcome everybody. My name is Jerry Hargrove, and I'll be talking a little bit about DevOps and new technologies today, specifically around containers. And just to give you a little bit of background, I'm a member of a group of solutions architects at Rackspace, and our role is to work with Rackspace customers who are making their journey to the AWS cloud. We provide sort of best practice architectural guidance and advice to customers as they're moving their way to the cloud to make sure that their applications and workloads are effectively cloud ready, working with them on things like high availability, high scalability, and fault tolerance, effectively to make sure that they're good cloud citizens. Today what I'm going to share with you, though, are some of those best practices, particularly those associated with customers who are running containerized applications on the cloud and being good container citizens. So let's go ahead and get started with that. The first question, though, that the first topic that usually comes up, though, when talking with customers who are using containers is really why containers? Why containers now? So, in sort of the evolution of the industry and technology, why are we using containers now, and why containers here? Why are you using containers for your particular applications? So I'd like to start with just a real quick overview of container history to get an answer to those two questions. The question, why containers now, is really just a part of the evolution of technology. Containers have been around for a long time, and they've actually been a work in progress for quite a long time. Their origins go back to even before, BSD jails, Solaris zones, well back into the 70s when we were working on things like chroot and process isolation, and the evolution of distributed computing just in general, from individual servers to virtual machines, and now to containers. Effectively, OS virtualization is sort of a logical one that's been a long time in coming. So the fact that we're using containers now is really just a matter of evolution, just like other changes that we've seen in the industry. So the next question then is, why containers here? Why as a customer are you using containers in this particular application? And oftentimes that's attributed to their popularity in recent years in developer circles. It's coming from a developer background, I can attest that, I like containers because, as long as I'm following best practices, my code works the same everywhere, whether it's I'm running it in a container on my laptop, on a server, as long as there's a Linux kernel underneath. And the use of containers can help me speed up my development and tighten up the feedback loop on changes and adjustments that need to be made to my container images, and can also help me deploy them more quickly. They help streamline development and deployment. Now, a lot of focus recently has been on development tools, but even more recently we've seen much more focus on production use of containers around orchestration and orchestration tools, and that's why we see a lot of interest in containers now moving into production workloads. So let's go ahead and start talking about some of the best practices that we've seen and established at Rackspace around the use of containers. The first best practice we're going to talk about associated with container images is around image size, and in particular, minimizing container image sizes. Container size is often a very important factor in the effectiveness of anyone's CI/CD pipeline. In a very dynamic, agile environment where we have very tight feedback loops, where we're making changes often, we're testing them often, and we're getting feedback often, non-optimal images, large images effectively, can slow deployment down of those images to containers and then subsequently delay feedback as a result of testing. So in order to reduce the size of container images, it's interesting to just do a quick refresher on the structure of Docker images. If you look at the diagram here on the right, you can see the sort of the basic layout of a Docker image. And without going into a huge amount of detail, Docker images are built using layers, and those layers contain things like the operating system, they contain libraries, third-party software, configuration files, etc., that are associated with your application. And so if you have large libraries, those will contribute to the image size. If you have large binaries, those will also contribute to the image size, as will the operating system. So it's important when you're putting these images together that, number one, use as small a base image as possible, like the Debian image or one of the Alpine images, so that you're not carrying around additional resources, services, libraries that aren't applicable to your particular application. If they are there, then every time you deploy this application, those will have to be copied over. The other thing is, don't install unnecessary packages in your application. Again, unnecessary packages, they're not going to be used. They simply add to the size of the image and increase the amount of time to move that image around. And also use Docker ignore. It's very easy to simply add files to Docker ignore so that when you do a Docker build, those aren't included in your particular image. Another best practice is, as you're doing installation of software in your Docker file, remember that if you're downloading something, you're unzipping it, expanding it, and installing it, remember to actually delete the original zip file. There's no reason to keep it in the image. So these techniques, like you've seen here, are often used to optimize image size. In addition to these methods, having an understanding of Docker's use of copy on write storage and how it changes to per container writable layer and use of shared image layers are important, so that if you're shipping a large file that is going to be written to by your application, understand that each time that's written to, that an actual copy of that will be made on the local file system. So if you have large writable files, it's best to optimize those and try a different technique. Smaller, more concise container images, like I mentioned, result in more operationally efficient deployment pipelines with tighter feedback loops, and systems can be more effectively and efficiently make use of available system resources like disk space, memory, and CPU. So the next topic that I'd like to talk about is running containers as root. When we run applications directly on our own computers, like our laptop or a desktop service, we usually avoid running as the root user or admin user unless absolutely necessary. And if you work in a corporate environment, that is something that is strictly enforced oftentimes. Not running applications as a root user is viewed as being a best security practice, so we don't want to do that. But when we run applications inside of a Docker container, very often we don't have qualms about running everything as the root user. And as a matter of fact, that's the default. So and it can certainly be the case that, you know, running applications in containers, we can consider those as effectively isolated and that they shouldn't be able to break out. And as a matter of fact, things like namespaces and control groups exist to limit what a particular process can see and use, like file systems or how much CPU or RAM they can allocate. But the fact remains, a process that is running with root capabilities could increase the risk of an application being able to use those elevated privileges to access unintended resources due to a bug, for example, in Docker or a misconfiguration. So it's always best to simply avoid the possibility altogether and run explicitly as a non-root user. And I've shown a sample Docker file here on the right-hand side that shows how to use a non-privileged user. If you don't have that user statement in your Docker file, it will run as the root user. It's also important to look at the source image that you're pulling from to see what user that source image is using, so that when you do inherit from that, you understand what level of permissions and privileges that container is running as. So the next topic I'd like to switch to, the next best practice, is container scope. It's very commonly heard in the container world that you should run each container, and each container should have a single process in it. Now, this practice espouses the separation of applications and services into their component pieces, each one of those pieces residing in its own container. I mean, and the benefits of this decomposition are similar to those found when we're building applications and architectures that we want to be highly available and super scalable. We can decouple those components. They're allowed to vary independent of one another. They can scale at different rates. You can use different tools and different languages on each one of these components, and they can have differing dependencies and libraries, etc. I mean, those benefits they're true, they're real, they're tangible. But the thing to be careful about is taking this too literally and applying it at too granular a level. You know, it sounds, it's a very sound argument theoretically, but in practical application, it can become a large burden to manage. You know, the potential fan out of additional services, metrics, and logs associated with all those different containers could negate some of those benefits. So what we recommend is that for most systems, simply using a role-based container boundary are often sufficient and provide more benefit. There's no reason to break it down as granular as you might find in some cases. So moving on from container images themselves, let's talk a little bit about container orchestration. As I mentioned, as we move from containerized development environments to containerized production environments, we start to see different types of best practices come out. And the first is really around orchestration of these environments. Orchestration, just a brief definition of it is, we like to think about it as including tasks associated with scheduling of containers, placement of them, how to replicate and scale them, how to resurrect them should there be a problem and a container die, when to reschedule, how to do upgrades and downgrades of containers. Orchestration also includes resource management like memory, CPU, disks, IP addresses, container images, service management like orchestrating groups of containers into a service, if you will, load balancing traffic to containers within that service, assessing the health of those containers. And so what we found is that when it comes down to actually choosing a container orchestration system, it can turn out to be a very important decision, and it includes, key factors like, when you're choosing an orchestration system, what are some of the features that are provided with it, what level of experience your team might have with it, licensing, for example. You might choose a particular platform like Amazon's ECS system or Container because your members of your team have previous experience with it, and it'll reduce ramp time and reduce time to market. Or you might simply choose an orchestration system because it happens to be open source and free. The one thing that we've found, though, is that oftentimes that orchestration system isn't what differentiates you from your customer. And when we provide recommendations to customers around orchestration, we often recommend choosing a managed system over a do-it-yourself self-managed system. Now, in the AWS environment, you have, because of the nature of it and the flexibility of it, you always have the opportunity to run orchestration on EC2, and you can run things like Docker Swarm, you can run Container, you can run Kubernetes, as well as other Mesosphere. There's a whole slew of them now that are coming out where you are then responsible for managing those. Or you can hand it all over to Amazon ECS and have them manage it for you. That's our best practice and recommendation, is that you use a managed service like that so you can focus on your particular application and not on the underlying infrastructure. One other thing to think about in terms of orchestration is just that container pipeline that you're going to be using. And I'd like to share with you right now a very common pipeline that we see that works well in development and in production. And this particular one here is composed of all managed AWS services and features. And for the benefits I mentioned before, we would default to this type of environment and making recommendations to customers. So just kind of walking through this environment from left to right just to give you some familiarity with it. In this environment, developers are integrating their changes together into a source repository on the left. In this case, it's AWS CodeCommit. AWS CodePipeline, just to the right of that, is polling that source repository, and when it detects a change, triggers execution of a continuous delivery pipeline with a new revision. That code pipeline then sends that new revision to CodeBuild, in this case, which builds the Docker container image from the source code located in the repository. AWS CodeBuild then pushes that newly built Docker container image to an Amazon ECR repository. Once that's done, CodePipeline initiates an update of the AWS CloudFormation stack associated with the ECS task definition and service, and then CloudFormation creates a new ECS task definition referencing that image located in ECR and updates the ECS service. ECS service then fetches that new container from the ECR repository, replaces the old task with a new one, and thus completing the deployment. And all of this can be entirely automated. Each of the components in this system you see here, whether it's AWS CodeCommit or Pipeline or CodeBuild or CloudFormation, you can actually interchange those with other applications and tools that are available, such as Jenkins. If you happen to be a Jenkins house and you're using that and you want to start with that, you can use that in case, you can actually use that in place of CodeBuild or CodePipeline or some combination of those. AWS CodeCommit is used here as a source repository. You could also be using GitHub, or you could be using Bitbucket, whatever your choice may be. This is a common practice to use. And it's also very easy inside of AWS to choose the orchestration engine. As I mentioned, you can choose ECS as your orchestration engine, but if you have a very simple environment that only has a single container or perhaps just a couple of containers, you can actually use Elastic Beanstalk instead. And using the same type of CI/CD pipeline, but pushing things out to Elastic Beanstalk instead of ECS. And so with that, I'd like to finish up this section on containers, hand it back over to Eric.
All right, thanks, Jerry. As you both, Jerry and I, like as Jerry said earlier, we both work on a team that we sit down with customers and we help them work through architecture. We help them work through how do you do what you're already doing or what you want to do in a cloudy way that's, secure, resilient, redundant, reliable, and all those different things. And so one of the customers that we've worked with is ScriptDrop. And we have today as a guest, we have Larry Scott, who's the CTO of ScriptDrop, and he's going to tell you about ScriptDrop and some of what we've been able to do with them. And so Larry, I'm going to turn it over to you.
All right, thank you, Eric. Yeah, about ScriptDrop, we are a healthcare startup focusing on two products right now. Our prescription delivery service is currently live in New York, and our second product will be released this summer, and that's our medication reminders for patients that they can interact through Google Home, Alexa, text, or robocall. So right now, we're currently a team consisting of 3 total members that all hail from Cover My Meds that recently had an exit that sold for approximately $1.4 billion. We're located here in Columbus, Ohio, and we're a prescription delivery service that's currently live in New York. So evaluating the solutions, why did we choose Rackspace? When we first started ScriptDrop, we knew that we would need help on the infrastructure side from day one. We searched around quite a bit to ultimately land on Rackspace. After having the initial discovery call with Rackspace, we felt very confident with their skills and expertise to build out what we needed to get our startup off the ground. I'm not going to lie, at first our initial thoughts were with going with Rackspace is, oh man, they're going to charge us like an arm and a leg and we're not going to be able to afford this. But however, we found the opposite to be true. They're very affordable and fit well within our price range, especially for the value that you get. So why Rackspace on AWS? Our experience in healthcare around infrastructure especially was always to be taught to build it in-house. When we started with that concept, we quickly found that all of those barriers were removed when we see what that AWS could supply us with everything we needed while staying safe in the cloud. When we initially started to look at AWS, we noticed there was a ton of products and services that they offer. And when we first signed up for an account, it was overwhelming, and we just knew that we were kind of in over our head. So once again, Rackspace showed us that we could ultimately be confident in what they had to offer and to get us off the ground so that way us as developers can deploy code easily and keeping our data safe in the cloud. And that HIPAA compliance is what ultimately sealed the deal for us. So our initial process looks something like this, where you can see we would start with putting code up to Bitbucket. It would be a feature or a new application. CodeShip would detect a change and test that out for us and prepare any artifacts that may be needed for that specific application or that deployment. Then we would manually push that code to AWS CodeCommit for it to be detected by AWS CodePipeline to use our AWS CodeDeploy strategy to deploy it to all of our EC2 instances. So some of the issues with this workflow is that there's manual steps that are required to make something go live. It requires the juggling of multiple repositories and storing unneeded code. And there was just multiple pipelines to manage. So the Rackspace Advantage, as you can see in this graphic, it's cleaned up. You know, we would be able to, us developers, deploy something to GitHub And then from there, AWS CodePipeline would detect that change, kick that over to AWS CodeBuild to build out any artifacts and prepare that deployment. And then it would use our AWS CodeDeploy strategy to get that out to our EC2 instances. So with their proposed story, they advising us to move it over to GitHub for source control that allows for a more native integration for our repository. CodeBuild replaced CodeShip in this particular diagram, and the better pipeline orchestration that we'd get, and we'd be able to deploy with CodeDeploy. So the improvements are one pipeline, fully automated, no more juggling of multiple repositories, and it would just single it down to that GitHub repository. But as we were heading down that path, we had two different interests here in ScriptDrop. We noticed that we wanted to start going down the Docker and container way, and Rackspace noticed that we were heading down this way of that proposed outline of work that was in the previous slide, and they said, hey, if you're really serious about doing Docker, the work that we're doing now will change significantly and it'll be a wasted effort. Let's explore what our options are here, and you can choose the way that you want to go. So they gave us the heads up, and it allowed us to pivot, and we ultimately chose to go to containers. So with containers, it allows us to stay consistent between environments. As developers, the struggle or the pain of having to have a development or a staging or QA environment that mimics production is a hassle to build and try to maintain that if you're not keeping up to date, or if you have some weird way that you're doing that. With containers, it allows us to stay consistent. We can put each service on this container, and we can subscribe to that separations of concerns model. And we can also think of it as the way of the insects versus cattle versus pets model. I'm pretty sure everyone's heard of that.
So I'm going to jump in there real quick on you. This is an interesting, thought, in the insects versus cattle versus pets. And I wonder, we talk a lot when in our industry, and when we're talking to people, we talk about this idea of cattle versus pets. But it's surprisingly, Larry, how much people don't really get this idea. So I'm actually going to jump in and explain it a little bit. When we look at doing architecture, especially when we're on premise and we paid a lot of money for these servers, we think of them as pets. If a server goes bad, we work to make it healthy again. We feed it, we keep it in blankets and watch TV all day to see if it's going to get better. I mean, we really dump a lot of time and money into them. But when you go to the cloud, you don't really think of it that way. You think of it more as cattle, which is something where, if a cow gets sick, then generally, you put it out to pasture and you put a new one in its place. There's not a lot of time spent on, bringing it back and making it healthy. And so it's the same with like servers in the cloud. If a server goes bad in the cloud or something happens, throw it away, bring a new one up. That's generally the methodology of cattle versus pets. But then you introduce this new idea of this insects versus cattle versus pets, and that's really where the container kind of thought process is it's a small, insignificant thing that you toss without even thinking. It's it's very it's very granular, very minuscule. And so even more so than cattle, if a process is going bad, if a container's going bad, you pop a new one in. No thought about it, no time spent there. So I think that's good that you bring this up, and it's an interesting approach on wrapping your mind around how fast can we spin up containers, how fast can we replace them if needed. So sorry to interrupt you, but I thought I'd throw that out there.
Oh no, that's definitely a great explanation. I appreciate it. So going back to this, the Rackspace enablement. Rackspace had the foresight to see where we wanted to go and call flag on the play and provide us with an even better solution. They extend their best practices for designing AWS infrastructure for containers and laying the groundwork for DevOps processes for containers as well. So we truly appreciate that. So with this new Docker container way, it looks much like the graphic that Jerry just showed us. We have that same proposed way, that standardized way that they lay things out for us. We'll commit code to AWS CodeCommit for AWS CodePipeline, and then have that test and built out using AWS CodeBuild and prepare any artifacts, and then pass that over to ECR or the container registry to deploy that out to ECS.
All right, excellent. Thank you, Larry. I appreciate it. You know, in working with ScriptDrop, one, they've been, you know, just really great to work with. They're technically, you know, they're advanced. They're doing some great things, and they're kind of a cloud story in that, you know, they're three guys, but because of AWS and the power of AWS, they're able to compete with, you know, well-established enterprises. So it's a great story there, and working with them, you know, I got to do what sometimes we get to do at Rackspace, and I got to call Larry up and go, hey, you know, we've got this plan to build this model for you. And that was the original model they had looked at to help you with your pipeline, get your DevOps story going well. But, you know, some of our guys have noticed that you're you know, fiddling around with Docker and looking at how do you do containers. So we got to talk, and really honestly, I got to say, look, it's a waste of money to have us build out a pipeline if you're going to change it in a couple weeks or a month or so. Why don't we evaluate this Docker approach and let us help you? I mean, we have expertise in house. Let us help you do it the cloudy way so that it works well on AWS, and it just makes for a fun story. And Larry, I appreciate your time coming on this to tell that story with us.
Yeah, it's truly been a great working relationship. We appreciate it, Eric.
Thank you, sir. And with that, Lex, I'm going to turn it over to you, and we'll answer some questions.
Well, thanks, gentlemen. That was really interesting and helpful. So now we'll take questions from the audience and see if we can explain ourselves more completely. So first question that seems relevant here is, how much did you save going from EC2 to the container service? I guess in this example.
So yeah, we definitely saved a bit on labor and definitely time. With our team here, we're mainly developers, so we're not infrastructure guys by trade. So we know a little bit about it because we dabble and we have to know how to navigate around. But having that expertise in-house that allowed us to run leaner, we didn't have to hire another person on staff, so it definitely saved quite a bit, and the time was super helpful because we didn't have to spend time learning how to do this. We could just rely on AWS with Rackspace behind us to get everything spun up. So it was definitely a savings on both ends from our part.
Great. Well, so here's another question. When deploying containers, what's better, Beanstalk or ECS?
So this is Jerry. I'll go ahead and take a stab at that one. I think a lot of it depends on the type of environment that you're running. And obviously there are some things to consider when choosing between Beanstalk and ECS. If you have, for example, a single container and you want to run it on AWS, then the easiest way of going about that is to simply put it in a single container Beanstalk instance. That makes it very easy to simply deploy that particular container, and you don't have to get really involved in orchestration of multiple containers. Now, if you have a couple of containers and you need to be able to scale those in and out, you can still use Beanstalk in a multi-container environment and build out fairly complex infrastructures that way. I think once you move beyond, maybe this is an arbitrary number, but maybe 10 containers, or it becomes much more complex, then you really start wanting to look at something like ECS, which gives you much more flexibility about scheduling tasks and services and allowing those different containers to scale independent of one another. So as you scale out and grow larger, ECS is an obvious evolution. You may want to start with Beanstalk if you just got a few, and then move to ECS as you grow.
I think that's a Great explanation. I think I've also encountered quite a few customers deploying applications on Beanstalk all by themselves in containers because they were legacy apps and relatively straightforward to deploy, where the customer didn't want to pull the application apart and build it in chunks or microservices. So kind of an interesting use case for Beanstalk, typically different than the ECS use case. Okay, so let's see, another question here. Where do Chef and Puppet fit in this picture that we've drawn?
I mean, from my perspective on, Jerry again, I think they fit in the same way that they do in a traditional environment, whether you're running on AWS or whether you just happen to be running in your own data center. You're still going to use them or can use them in the same manner that you've used them before. So I don't see any real significant difference. If you're a Chef house or a Puppet house and you want to continue using those for configuration management, even in a containerized environment, I've seen customers who have continued to do that with great success.
All right, very good. Along those lines, how do Beanstalk and ECS handle logging? And for instance, would they integrate with an SEIM like Sumo Logic?
Most, I think most have agents that you can actually install in containers. You can have sort of sidecar containers that are running in your environments like ECS, whose sole purpose is to do logging. In many cases, with orchestration engines, ECS included, if your containers are piping log information to standard out or standard error, you can feed that directly into CloudWatch and CloudWatch logs. And the same is true with Beanstalk. But like I said, you can use Sumo, you can use Loggly. A lot of those will provide either containers in and of themselves that you can configure your containers to ship logs to, or you can install agents on your containers and have them ship logs off container. But the key point there is obviously in this type of environment to get that log information off of those containers as quickly as possible because you should treat them as ephemeral, like Eric said, as bugs in the pets, cattle versus bugs type of scenario.
All right, very good. Thank you. So thinking also about other ways, other things one has to do with containers, where is testing done with a container architecture and what technology does the testing?
In the containers, I mean, in the environments that I've seen and worked with, it's very similar to a traditional CI/CD pipeline where you're going to build out your pipeline and you're going to include test and testing stages where you can actually perform some automated testing. And again, the same types of tools can be used that you're using in your current environment. So whatever test tools you're using, you use those same ones, put it into a CI/CD pipeline like CodePipeline and have it trigger those tests to happen and automate feedback into the development environment. So again, in that sense, it doesn't change that much, but you continue doing the same thing.
Okay. Interesting question here. I can see how this fits when code is actually being written by developers. What about off-the-shelf products from vendors, I guess, meaning commercial off-the-shelf software? Do these fit in the DevOps and container model?
So I think so, that, and that's often, and I think you mentioned this too, that for legacy software, even COTS, commercial off-the-shelf software, you may want to containerize it and put it into a container, unless there are some specific requirements that would prevent you from doing that. I don't see any reason why you wouldn't.
Okay. So here's a Rackspace question. What was the worst pain point for Rackspace moving from virtualized hardware and code deployment to a container process? maybe it's an opportunity to tell the Rackspace container story a little bit as well.
We transitioned and started providing Fanatical support for AWS. We had to build out our own internal infrastructure and tooling to allow us to work with our customers and to provide interfaces for our customers to work with us and our systems and backends. And internally, we use Amazon ECS and containers, and it provided the same benefits that Larry mentioned as he seeing in his environment. That is, increased agility, turnaround time, and feedback time, and provided us with a way of scaling our system out on AWS at a much more granular level than perhaps if we had gone the route of using EC2 instances natively, for example. But on the back end, it's worth mentioning that our entire back end that's used to support our AWS customers is running on AWS and in a containerized environment. And very much of that, a lot of that is serverless as well.
Very good, thanks. It looks like we're running out of time here. We really appreciate these very interesting questions from the audience and the audience's time and attention. So we're going to wrap up on that note, wrap up today's webinar. And as a reminder, you'll receive an email within the next 2 to 3 days with a link to these slides on SlideShare. Thank you very much for attending. And if you have any other questions, please don't hesitate to reach out. Thank you.